To finish up section 10.3, we now need to look at partition numbers. In general, given a function f, a partition number is a value of x such that f is discontinuous at x or the function's equal to 0. Discontinuous is what we just worked with, so if there's any breaks, then that would be an x value of concern or a partition number, or where my curve hits the x-axis, where it's a 0. That's another value I need to know about. Partition numbers determine open intervals in which the function does not change sign from positive to negative or negative to positive. By either using a test number from each interval or our calculator, we can construct a sign chart for the function on the real number line. And once we do that, it's then very easy to solve these inequalities where my function is less than 0 or where my function is greater than 0. So I have got two problems that we're going to look at, and it does say using a graphing calculator, and I'll be getting my graphing calculator up here in just a second. So first thing I'm going to do is graph my function. I put both of them in. I've turned y2 off because I only want to look at one at a time. So you need to graph your function, and normally I do a zoom 6. Now anytime my function is within plus or minus 4 with respect to my origin, I usually will then do a zoom 4 to get a little bit closer. It's my decimal window. Okay, now this curve is continuous. My domains are real numbers. So I do not have a partition number that does not lead to division by 0. So I don't have to worry about that. But I do have two zeros here. And you need to know how to find a 0 on your calculator, and I'll do that for this particular problem and the next. So for me to find my 0, I've got two of them. Me being a creature of habit, I always do the left and then anything after that. So I have to hit second trace for the calc menu, and there's the word 0. Now some of you might have learned how to do it by using cursors, but I choose values. It's a little bit faster. So it asks me for a left bound to the left of what I want. I want that 0. So it's to the left, so I will use that. My right bound, I'm going to use an x value of 1 because it looks like my 0 is between 0 and 1. So I hit 1, hit enter, and it erects boundaries, and I'm telling the calculator you have to look between these two boundaries for any place where it hits my x-axis. I don't guess. I've done enough work, and you've got to get this word 0. Now it's set on here to round to 2 decimal places, so my 0 would be 0.51. Now on my number line, this is what my function is, this is what my x value is. So I've indicated that it hits the x-axis in 2 places. So my first one here, let me move this just a little bit, come on, is 0.51. Let me get my calculator back up. Okay, let's go get the next 0. So second trace for number 2. Now this one, that value is between, it looks like it's very close to an x value of 2, so I'm going to type in 1, type in 3 to set my boundaries, and remember, I do not guess. This right here is what I call Oz, the obnoxious 0. It is telling me I have a 0. Why it can't give me a y value equal to 0, I don't know. So don't worry about it. I just know I'm looking at that, and that is on my x-axis. So my other 0 is 2.12. So let me get rid of this block. So that's how I start labeling my number line. Now to label the top, I said you can either pick a number. Now I'm going to show you a quick way on how to pick a test number. So I go back to second trace for value. It's really quick. It's prompting me for an x. I need to get an x value on this side, so let's use -1. I've got a positive value, so I'm going to have, my calculator's going to disappear again, so let me move this. There's my positive. Remember, my function is 0 at that place. Now I'm going to use a value between 0.51 and 2.12, so I'm going to use 1.25 just to be different. And it should give me a negative, because if you'll notice, my curve is below the x-axis. So there's my negative. So I'd have a negative here. I'd have a 0 here. Now, if I pick a number over here, think about this. If I pick any number, if you'll notice, my curve is above the x-axis, it's going to be positive. So let me go ahead and get rid of this box. Let me get back my calculator. I'll go and choose a value. Let's choose an x value of 4. When you ask for value, you just type in the x values. There's a positive number. Now guys, you can use a test value. I think the textbook videos does that. Or you can just look at the curve. If your curve is above, it's going to be positive in that section. If it's below, it's going to be negative. So pretty much I look at my curve. It's just faster, and it does the exact same thing. So I really don't care how you go about finding your signs. Let me put that down. Now to answer the question, my function is going to be, when it's greater than 0, it's in the sections that are positive. So from negative infinity to 0.51, and then 2.12 to negative infinity. So that would be how I'd expect you to answer it. When my function is less than 0, is in the sections where it's negative. So a parentheses, 0.51, comma, 2.12 should be my answer there. Now let's look at this one. This has partition numbers not only where the function's equal to 0, but also where it's discontinuous. I have to take all of those into consideration. So let me go back to y equals. I'll turn this one off now. Let me go down and turn this one on. Let me do a zoom 6. I always do a zoom 6 first. I'll pull it over here. Now if you have an 83, your 83 will have these lines that come through at -1 and 1. That's just how 83's graph. The newer ones, the 84s and the TI Inspires, they've taken care of that. But guys, set your denominator equal to 0, and you're going to find out the sections where the curve is not defined. Those have to go on here, and if you'll notice, I've got 1, 2, 3 zeros. This is why I have got 5 slashes here. So let me go ahead and get rid of this box, and let's see how I've come up with some of those things. I know it's a 0 here. It's not defined. My function's not defined at -1. It's 0 here. It's not defined at x equals 1, and it's a 0 here. So I label what my function is first, be it either 0 or not defined. Now let's see about the signs. See if you can see on the calculator. To my very first place, my very first 0, if you'll notice what my y values are, they are negative. Between this 0 and where it's undefined, my curve is above the x-axis. It's positive. Between where it's not defined and 0, notice that my curve is below. It's negative. From this 0 to this not defined, it is positive. From not defined to this 0, it's below or negative. And after this 0, my curve is positive. So you see, I can find all of this information up here before I ever go find out what these are. Let's go find some zeros. So second trace number 2. So that one looks like it's near -2. So my left boundary, I'm going to put -3, enter, -1, to erect my blinders, then hit enter. So to 2 decimal places I'd have negative 2.33. So won't you write that on your sheet? I'll move this in just a second. It's not defined at negative 1 or 1. Let's go find the middle 0, that one right there. Second trace for the calc menu, it's between negative 1 and 1, and I don't guess. So this one should be 0.20. Let's go get this last 0. Second calc 0, and it looks like it cuts through between 2 and 3, so I'm going to put 1 and 4. So 2.13. Let's see if that's what I've got. I believe that's what I said. Now, where is the curve, my A part? Where's my function positive? Any section that has a positive, I'll have here. So let's see if I have parentheses negative 2.33 up to negative 1, then another parentheses 0.20 comma 1, and then another parentheses 2.13 to infinity. So that's where my function is positive. Where my function's negative is in the sections that have a negative. So there's that one. So that should be about it for this particular section, because we had to do continuity and partition numbers. And that's all for now. Thank you. Bye-bye.